Hello everyone, good evening. Good evening and welcome to day 20 of our AI with NVIDIA Masterclass. Good evening all. Am I audible? Can you guys see my screen? Good evening. So in this particular session, we are going to first make an inference of our previous day's output, which we got successful. Yesterday we couldn't complete, so we'll be doing that now. And once that is completed, we will be going into the next step. Okay. So the next step include we have to actually go and take care of one thing, which is the pedestrian detection, and we are going to do it combinedly today with vehicles, pedestrian, and traffic signs detection together in a particular output. That's what we are going to see. So are you guys ready? Can I get some response in chat box? Can I get some more response? Good evening. So, what is the project we have seen in previous class? Can you guys explain or tell me one out of it? So, we have seen multiple projects, right? So, in the previous session, we have tried to train the SSD using the Jetson Inference from NVIDIA, right? So, we have tried to do it, but we got stuck. Especially, we have tried to train the model. So when we tried, the storage was a problem, then we also trained it. But the problem is we couldn't make the inference because we haven't made the install. So it's a mistake from my side, which I have to, let me just go for, let me show you the example. So in this particular session, we will be looking at this project. And before that, let us go for the previous day's output. So good evening all. Can I get more response in chat box? Why is it so silent in chat box? Can I get more response? So let us go for the inference. So let me go back once again into the site which we have followed yesterday. So let me go for Jetson Inference actually here. Okay. So here we went into the Jetson Inference. This is what we have followed in the previous session. So we'll continue from that actually now. So looking at that, when we go or went below, we have seen that the collecting your own detection data set. So we followed this, we made this capture control data creation, but we just had just 4 images because in live I can't take 100 images and all. So what then we did is we personally tried to collect for 2 classes. So it's a toys data set. So we had 2 toys in our office. So we are trying to create a data set of it. So we have a teddy bear and we have a Doraemon toy. So we created 100 images for each, made using this SSD collector. Okay. So once the data has been collected, we have went into training it for literally 2 epochs I hope so. So only 2 epochs it has been trained. So once the training is done, we know we have to export it to Onyx version. So the Onyx file is available. Then you can go for running the inference out of it, right? So let me go into the console. So here we are. So let me open the terminal and let me go into that particular directory for you to show what all things we have and what all we are going to make the inference first. Then we go into today's project. So let me go for ls, and we have the folder which is Jetson Inference. Yeah, so here we can go into Python. Okay, so we can go into training, we can go into detection, then into SSD, and now if you look at the contents, okay, so you can go into the models to check the old original model, which is the SSD model, as well as we have the toys model now. So if I go into toys, you should be able to see the PTH version, the version 2, the epoch 2 has been saved and we have converted it into the Onyx version so that it can be run. So it has been optimized and we have the .engine file from the output, which is the TensorRT format, so you can make inference, faster inference out of it. So if you want to make inference, actually initially itself you have to move into the Jetson Inference and build folder, you have to make it. So when you make it, you have to also run install. So that will help you to get the detect net. That's what the issue we had earlier. So I'll come back. Also, I want to show you guys the image dataset which we have. So we have collected 100 images totally. I think 204 or 207 images available. So if you want to look at it, let me show you. So the data set is actually inside, we have it inside of Python, training, detection, SSD, data. So you can see we have a toys data set and we have a JPEG image, as you can see. So this is the data set we have collected. Okay. For the first class, which is Doraemon, see we have literally collected more than 100 images, 100 to 105 images. Okay, so we have a lot of images for this with different orientation, different angle, different zoom level, different lighting, different background it has been taken. Okay, with a tool like we seen in yesterday's class. After that, we have another class here. So this is a small teddy bear. So we have also taken it in different photo angles. Okay, so I marked it, and all the annotation details and all available here in this annotations. Okay, for each file we have the directory of it. So then we have trained it, and once you have the trained model, you have to run the inference code. So let us try to run the inference detectnet code. Let me try to get it from the history actually, or else we'll try to run it again from freshly because it's a huge command. Yeah, so here it is. So can we see the inference after training? Let us see how does that work. Okay, so let us try to run it. Yes, running in TensorRT, and you should be able to see it with little bit lag, but here it will run faster. So let it open. First time when you run this inference, it will actually convert the Onyx version to the engine version or TensorRT version. So it may take some time actually. The first time it will take around 10 minutes. Once it is completed, the inference it will be running very faster. So you should be able to see it is opening quickly. It will open and it will run. So as you can see now, it is detecting the teddy bear. So also it is detecting the Doraemon. So this is custom object detection. So as you can see, based on some issue in the lighting, it is actually giving you some wrong inference. So as you can see in different angles. So you need to train more. It has ran just for 2 epochs, and this is what the custom object detection we made, and it is actually predicting well, right? So it was able to do it. So this is the result for the previous project. So you need more images. Nearly 100 images is what they are suggesting. Okay. So you need somewhat around 100 images for each class, and you can train it like 10 epochs or 20 epochs to get better results. So this is the custom object detection which we have planned for doing in previous class, and this is the inference out of it. So are we clear with this? Can we go into the content of this session? Can I get some response in chat box? Yes. Let me clear some storage as well. Sudo auto apt auto remove. it fine? Can we move into the next topic, guys? So today's part, actually we have to go into the home directory. First let us look at the output. I think we had some issue in that, so let me try and then we can go into how to achieve it actually. So we have all these contents available. So today what we are trying to do is, if you have a camera in your dash cam, okay, in the front of your car, so you are going to create, for example, what will happen? So when you do it, actually you should be able to see some inference. For example, you should be able to see some vehicles. You should be able to, in vehicle itself, you should be able to see cycle, car, then trucks, then what else? You can have bicycles, you will be seeing pedestrians, you should be seeing traffic signs, signals and all, right? So to classify all these things, we are going for a data set which is called as BDD. It's from Berkeley. They have created a huge amount of data set, and that's what we would be preferring to use in this session. Okay. So before that, we'll try to run this and then go back into the inference. Actually, the training hasn't been completed yet, so I couldn't be able to make inference. So I have to like show it in the upcoming session. But anyway, we'll try to just run it. So this data set is a variety of data set. It has all the vehicle information. It has all the contents of the road, like vehicles, pedestrians and all. So we are fine tuning it to just focus on that and create. Okay. So for doing that, let me come back, and we need to begin with the darknet. How many of you have remember darknet? So darknet is what we have used earlier for YOLO, right? So we need a YOLO v3 model. So you can go into Alexi AV darknet. So this is a profile where you can get the darknet, and darknet, if you clone this, and you have to also go into the make file, and then if you have the GPU, CUD and then OpenCV and all, you have to change this into one using Vim. You can change this into one, and what you have to do is you have to save it and then run make, and that should be able to make, which means it will set all the details for you to run. So once that has been done, you can actually go and go into the next process. So the data set we are going to choose is BDD 100K data set. Okay, so let us have a glance about it. So this BDD 100K data set, let us go into their site. It's from Berkeley's diverse driving video database. Okay, so you have a lot of data set for different varieties available. I think there is a particular website. Let me try to go into that. So this is their site, and you can see they have paper, code, documentation and all. Okay, and data and all. So if you scroll below, they have data set for example, they have for different tasks. It include object detection, especially for driving. Okay, instant segmentation, multi-object tracking, segmentation, lane marking, drivable area, image tagging, limitation learning and all. Okay, so if you look at the data set, for example, this is all the varieties. So if I just go and look at detection data set alone, You have for object detection. Then image segmentation means segmenting the particular vehicles. Then semantic segmentation will give you everything. It will be classified into any class segmentable. Then drivable area data set. So you can also collect the drivable area. So if you want to detect the lane, the primary and secondary lanes, then box track, okay. Then segment tracking, post estimation of the pedestrians can be done. So if you want to look at their data set, you can go and collect the data set. Okay, so for each, for example, we are interested in object detection, right? So we try to go into that. So for example, they have a GitHub repository to download, as well as I think there is another download links which will be available. So this is the 100K data set. Okay, so as you can see, this is the site. You can directly download. If you click at that link, you have variety of data sets available. So there are 10K images training, 10K testing, because it's a huge, right? It is very huge. So 100K means it goes to the GB size will be very high. It will be 6 GB, 7 GB. The Jetson can't actually store all those things. You can store it somewhere else. You can then train and take it back here, or you can also go for some low size images here. So what we did is we have tried to collect some validation images, because it will be of very less size, 100K validation images, and then their label as well. So you can actually download it. So when you download it, you should be able to get it. For example, let us go for road segment test data set BDD 100K data. So this is what we have. We have a train folder which has the data set. So you can look at this. Okay, so this has all the different variety of data set. It's actually pictures from the dash cams, right? So you have all these pics. So it will be annotated as well. For example, it's a variety of data. You have nearly 10,000 data sets here. So 10,000 pictures. So for each picture, you can have vehicles, trucks, pedestrians, all of them will be included, persons. Okay. So this, whatever the image respective is, you have their detail under this train.json. So this has, for example, what's the weather, what's the time of, what's the scene, and any object, what is the name, it is traffic sign, what's the coordinate. Okay, so then what is other things, you have other details as well. For each image you have all these contents available with us. So you have detected a car and this is the coordinate. So for combining these things, we will be using another repository or another set of code. So that, let me explain. We have it inside this BDT 100K. So if we go inside this, okay, not this one. So let me go back into our Jetson actually, and let us open the terminal. Yeah, so let me go back into the darknet which I have. So it's a tedious process, because you already have a YOLO v3 file, tiny version. We are going to take it and we are going to feed this new set of images to train. So the training will be running for a lot of time. Okay, so let us go back into the folder which is called as EDD. That has been removed. And in such case, let us go for, so that's a repository, YOLO v3 EDD. Yeah, here it is. So let us just clone this first. So git clone. You can do it on your Jetson as well. So that's where we will be working, but it's not ideal for training. Again, I'll tell you, it can go for best inference. For the video dataset, you can search for in the internet only, because for Actually, the traffic data set you can get it from the BDD 100. They have video data set as well. Please look at that site, BDD 100K. Okay, so let me change the directory into capital BDD tiny and look at ls. Sorry, which means the directory here in Windows. Okay, so here, if I look at this, okay, so we have all these files. You have the data file which has the data names and all. So if I open just with notepad, okay, for example open with notepad, you should be able to see the directory names, okay, which is inside this. You have all the details, then the names actually, so you can also open that with notepad. So all the class names are available. Okay, so this you can also go into the config where you have the config file. So if you open with notepad, so this is a file which is nothing but which is going to tell the YOLO what is the version, how much training should be done, what's the batch size, what's the learning rate, and then the model configuration is available here. So this is a configuration file for the model. Okay, so all the classes and all available here. So what you have to do is you have to follow this readme file. So if you just go into that, you should be able to see. So this data set you can collect. We have a limited data set. What you can do is you have to clone the darknet either from PJ-Ready, or you can also go for AlexEB. That will be better for darknet. So once you have collected, okay, so you also have make sure that you have the folder where you have images. Okay, so your folder will be something like this: data, your train and JSON files. So what you have to do is you have to run it in a particular file. So here in this particular GitHub repository, you have this utils, right? So you have files like labels to text. Okay, so you have a folder and you have a label, right? For images, if I open with Notepad, you can see it is a Python file. So some of them are missing because this is a custom, and your dataset has some other details, like it has other classes like other persons or the other vehicles and all. So you can create them here. You have to manually add in this dictionary. So once you've done that, actually what you have to do is you have to pass two things here, argument parser. So hyphen L will be nothing but the label path, which is the image path. Okay. So sorry, it is the JSON file path, like train.json file, which I have shown with the custom all the details of it. And then hyphen D is the directory for the image. So when you run it, what it does is for each file it is going to create a .txt file. For each, it creates a .txt file from JSON. It will have the image name and the respective coordinates, classes and all. It will be done automatically in this code. So once you have completed that, you can also use this remove images without labels, because some of them, if they don't have labels, you have to pass the label with the image directory as well as the directory of the image and label. So when you run it, if it is not existing, it is going to remove it. Then finally you have to run this test validation txt file. So what this does is it creates files for you. It splits them into training and directory separately, and then gives you the path that will be your output. So with all these things, okay, you have to take it and you have to put it in a folder. Maybe for example, create a folder in the name vdt 100k data. So in that you should have this train txt and validation txt. This both will be available when you particularly run this test val txt.py. When you run this, you should be able to get this train and validation txt. This dot data and dot names are available from the this particular folder. You just have to copy it. Okay, from data you have these two, you have to copy and paste it in the same folder. Then also you need to download this configuration file. So this is available inside of this config. You can just copy this and you have to paste it in the same folder. And you also need to create a backup folder, which means when you train, your trained weight will be available in this backup. Once you have done all these things, we have also done, and let us show the particular file where it is available. So let me open the terminal. So in the same name, BDD 100k data. So if you look at it, you should be able to see the train.txt, validation.txt, the configuration file, the darknet file they have asked us to download, you can download, and then the data file, .names file, and then the backup folder. So if you move into the backup folder, okay, and look at the contents, you should be able to see the final weights.file which has been saved after training. Okay, so once the training is completed, you should be able to get it. And the training takes actually a lot of times, and before going into training you need to adjust this YOLO v3 tiny file, because I didn't have time to actually train it for a long time. So what I did is I tried to modify some of the versions here. So actually it was just allowed to run a maximum batches of 5, which means just 5 iterations. Nothing will happen in that. Okay, you have to actually train for a longer time. So just based on time constraints, we have just went with the lower version. But anyway, it was able to save. Also, we had other extra classes, which is 13 classes, not 10. So if you go for 13, wherever you have this YOLO, you will be having in 2 places, here and the bottom in the configuration file. Change the number of classes, and then when you change the last convolution layer, the filters should be changed. It is nothing but the number of classes plus 3, okay, multiplied, for example, multiplied by 3 actually. So it is something like 13 plus 3 is 16. Yeah, multiplied by 3 color channels. So it is the number of output, which is 13, then plus you can go for 5. So that's the formula. So it will go to 18. So 18 into 3 will give you 54, right? So that is the result. So you have to change it if you are changing the number of output. Otherwise the layers won't match. So once you have done it, okay, so let me press escape and write and quit. So if you want to train this particular model now, you have to actually go and run this command. Okay, so you can call darknet, then training data is inside this dot data, then the model file is inside this config. The model is available here. If you run it, it will use the configuration, and based on your configuration it will train. So once you have trained, you should be able to run the performance, and that is how you make inference out of it. So this is where we are actually getting some issue. Actually it was not able to perform well. Let us try to make inference first, and we'll try to see what's the issue actually. Possible we'll try to make the inference now itself. Okay, we don't have the video file available here. So can we see the inference? Are we clear with what all the training steps has been included? Maybe by the end of the session I'll start the training so that you can see how the training works. Because if I run it now, it will alter the files which is already available. So that's not I want especially. So and today and tomorrow will be the last few days for you to join the internship. All these codes readily you will be able to get with trained model and all. If you guys are interested, you could still join by clicking at the link which is available in chat box. Register and get the benefits. Okay, now we are actually seeing a demo, and I think the detection has not started. It is not detecting anything, right? We have to actually train for a more, and this is not TensorRT version as well. It is not optimized, so it is actually going frame by frame in my main screen as well. Actually this is the training video, but it should have been able to do it, but the training hasn't been done for a longer time. So this is how the inference will be made. Let us see whether even it is able to detect any one thing, because we have to train it for a longer time. And hopefully in the next session I will be coming with a trained model so that you can see inference like we did in previous class. Today we are able to see the custom object detection, right? After collecting and training the data, it takes time, but still the result will be fruitful. FPS and all fine, but the objects it can't detect nothing. So yes. Well, let us try to make a training out of it. So for doing that, we have to actually pass this entire thing. We have a configuration, so we can actually change the configuration. What if let us go for let me go into the BDD. So let me change the configuration file vim YOLO v3 config. So here I just want to run it for a few more time. So maybe I'll change the maximum batches equal to, let us try to run it for some 20. I don't know whether it was able to complete by this session. That's the problem. So the steps is also going to be changed. Okay, I think I don't know what that. Let us try to run it again and then change only the things which we require to change. 16 and 18. So at which steps? So we can give at the 80th and 90% of your entire number of batch. Actually, the best number of batches is number of classes you have multiplied by 2000. For each class, you have to run 2000 iterations. But you know, right? It takes a lot of time. I can't handle that many now. So maybe we try to go for something like 30 or 30, 40 something, then we'll quit, write and quit. So let us go for the training code. So for that I'll come back to the home folder and then I'll paste, and this darknet file is actually available inside of ETD data. Yeah. So now when I run it, it will be starting the training part first. It will verify. So it is the detector train code. The data is available. The configuration is available here. The model is available here. Take and train. Okay. And remember, the number of iterations should be third number of classes multiplied by 2000. How many classes you have, you should be able to run that many times. So this is actually a inference chart. I hope so. So it's utilizing CUDA. See here you should be able to see the loss whenever the loss updates, you should be able to see over the epoch. I hope so. So let us try to minimize this. Okay, this is maximizing. Minimize it to a smaller window. As you can see, the training has been started, right? So maybe today or tomorrow in the next session I'll show you the trained output actually. So are we clear with the process of how it has been done? Okay, it has completed 2 epoch as you can see. And the loss is 716 above. So after the respective epochs, it will be cutting off. And yeah, so today and tomorrow will be the final days. You can still convert the masterclass into 1 month certified internship on NVIDIA with AI. And when you join, you should be able to get all these benefits such as 30 days of recorded sessions, 30 days of PPT, exclusive project codes, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of access to LMS course, assignments and tasks, weekly live sessions, resume building and mock tests, internship and participation certificate. All these things you could get it at a discounted fee at just 999. The registration link is posted in chat box. It's pinned in chat box, available in description. If you are interested, you could join and get this wonderful course along with all these benefits. So yeah, so today I think we have seen how to make the particular files, but the problem is the training is going on. Once the training has been completed, now it's a 4 epoch has been completed, okay, which is 0.1%. I think it is in 5 minutes, right? You have to run it more time, for example, nearly 1 hour for just the number I have mentioned that. But actually, when you want to make inference, when you want good results, you have to run it for nearly 13 into 2000. What will be the value? It is 26,000 iterations it should run. But as you know, Jetson is not a place for you to make inference. It is a particular thing, it will struggle. Okay, so you can train on some other cloud or any other GPUs which you have, but you can run inference. We have seen it is running inference, but it is not able to detect what we are trained it because the number of epochs is less. When you train it for more time, it should be able to be detect, and maybe I'll come with a fine-tuned model in the next session for you to show the inference in this particular one. So that's it for this session. So now the 5 epoch has been completed. So the attendance link will be posted in chat box. Please wait. If you have any your names are missing and all, you can contact the support team. The number will be given in description. You can message them or contact them. So they should be able to guide you and help you through this. So 6 epoch has been completed. So I think we can see the result in the next session. But today we have inferred the result of the previous session. It was nice. So like that, if you want to detect any custom objects like any other objects other than these toys, you can also train in the same way. So it's a denotion that you can give custom name and train like create a wide variety of data with variability, nearly 100 images for each class. You should be able to go fine. You can clone the Jetson Inference for internship users. We will be providing you all the step-by-step instructions, so you should be able to do it. So that's it for this session. Thank you all for joining. I hope we will be seeing in the final session with the final project. Thank you all. Thanks for watching. Thank you. So I think today we won't be having any attendance. So no issues. You can, since the other steps, certification and all started, there is no attendance. You can leave the session. Thank you. No need of attendance. You can leave the session. Thank you.